Welcome to qnawire.
In problem 114, we are looking for the center of gravity of the steel wire. To do that, we'll find the centroid in the x, y, and z direction using this equation where the centroid in one direction, in this case x, times the total length of the wire is equal to the sum of the centroid of each component of the wire times its length. And we'll split it into four components. We have this curved piece, which I'll label number 1. This straight piece here, number 2. I'll call the vertical piece 3, and the diagonal piece between y and x 4. First, let's find the centroids of each individual component. So for the curved piece, finding its x centroid, we're going to have to do a little integration. So looking at this xz plane and the curved piece, we can find the centroid by taking the integral of a point on the curved piece of wire times a change in length of that wire and integrating across the entire wire over the integral of the change in length. We know that x is going to be equal to the radius times the cosine theta to any point on the wire. And the change in length is going to be equal to the radius times the change in angle, which is the formula for arc length. And so plugging these in, we get r squared cosine theta d theta in the denominator, and then r d theta in the numerator, and this is all going from 0 to pi over 4 because it's a quarter of a circle. Sorry, pi over 2 actually. And solving this integral, we get 2 pi, or 2 times the radius over pi. So now we can plug that back into our table for the centroid in the x direction. And plugging in the radius, we get that the value is 1.528 meters for the centroid of the curved piece, piece 1. Now the second and third piece of wire lie on the YZ plane, so their centroid is 0. We just take half of the fourth wire in the x direction for its centroid, right in the middle, 1.2 meters. For the y centroid, the first two wires are in the xz plane, and so their y centroid is 0. And for 3 and 4, it's just half the height, or 0.5 meters of each wire. Now in the z direction for the curved piece, we're going to use the same formula, 2r over pi, because the quarter circle is in between the x and z. It's on the xz plane in between those two axes, so it's symmetrical in that way. For wire 2, we'll just take half of its length to get its centroid, 1.2 meters. And the third and fourth wire on the xy plane, and so their centroid is right at 0 in the z direction. Now we're also going to need the length of each component as well as the sum of the lengths. And so the length of a quarter circle is pi r over 2, which is equal to 3.770 meters. And we're given the length of wire 2 and 3 in the problem. And we'll have to use the Pythagorean theorem to find the length of wire 4. So we take the square root of the square of two sides added together, which gives us 2.6 meters. And summing them together, we have 9.77 meters for the total length of the wire. And now we know enough to solve for our centroids. By using this equation shown previously. So we put in the total length on the left side of the wire, set equal to the centroid of each component times its length. We can solve for the centroid in the x direction, which is also the center of gravity in the x direction. And we can use the same equation to solve for the centroid or center of gravity in the y direction. Summing up the components, centroid times length on the right side of the equation. We get 0.1842 meters for the center of gravity in the y direction. And lastly, we have the z direction,